Hello students, last time I had told you about the compound light microscope and I showed you an example of a binocular microscope. Today again I will be giving you a detailed description of the binocular microscope, but in the class you will have to go through the uniocular compound light microscope with a single stem, and see this is the difference between that. This is a single body tube and a single eyepiece, and here is the body tube is the same. It is using a prism. It may be using a prism or a reflectors, but here this is absolutely using a prism and is diminishing the body tube. The body tube is being diminished, the size is being diminished, and the eyepieces are so angularly set that there is a prism apparatus for the reflection. You know in the physics that the total internal reflection, utilizing the principle of the total internal reflection of the light, keeping a right angle prism in this talk and all this area, you can reflect light onto that thing. That is a different thing. You will be in class, you will be reading about this thing. Here this is the body tube and this is the eyepiece. Here there is no significant body tube, but this is the eyepiece. The two eyepieces are 10x. Here you can see clearly 10x is the magnification, and here this is a nose piece, a revolving nose piece. It revolves around here. Revolving nose piece contains 4. In the class you will be having 1, 2, 3, a low power objective, a high power objective, and a oil immersion objective. Here only 2 are visible, but here there are 4 visible eyepieces, and there are two low power objectives, possibly two low power objectives, and here this is one is written here. This one is a low power objective, is written 10x. You can see it is clearly written 10x. Here it is 10. Here it is 10x, clearly written. The yellow jacketed one is 10x. Here this one also is a low power objective, but I will not be going into this one because this is more important. This is the high power objective. See, it is clearly written here. It is clearly written 40x. That is 40x. There is clearly written 40x, and here is the oil emulsion objective 100x. I will not go into the details of the thing, but I will go into the parts of the microscope. This is a self-optical illuminated microscope. You can see as I switch on the lights will appear, and light will traverse from below a bulb, and it will be reflected onto not reflected. There are no reflectors. Here in the uniocular microscope you will be having a plane mirror and a concave mirror, a set of plane mirror and a set of concave mirror, and a plane mirror, and you will know that the plane mirror apparatus is being used for the oil emulsion objective, and the concave mirror is being used for the low power and the high power objective. Going into that thing, there are no foot here in the in the other YouTube segments. You can see and read about the uniocular microscope. I will be detailing you about the stages and the magnification and all those things, about the details about those things that are being needed in our experimental physiology. What is important is that I will be tilting this one, and I will show you that here is the light apparatus, here is the iris diaphragm, and here by increasing the light I am increasing the aperture, and increasing the light I am decreasing the aperture to a 0 by moving the iris diaphragm. This one is the iris diaphragm. You can see it clearly in the video. This one is the iris diaphragm, and here is the condenser. This is the condenser and iris diaphragm set, and you see it can be moved. It can be put up in the up position, and it can be put down position. It can be put in the up position, it can be put in the down position. And in our system, when we see any object under the oil emulsion objective, usually in the uniocular microscope we use the plane mirror. The condenser position will be up, and oil. So OUP, Oxford University Press. O for oil, U for up condenser position, and P for plane mirror. You have to remember this thing. Now I am not going into the details of this thing, and I will be going straight into the nose piece and the stages. This is the stage of the, this is the stage, and this stage can be removed by this pillar. This one is the movement of the stage. Here this you can move the stages from to and fro, and here this one is the this one moves the stage towards the magnifying apparatus and away from the magnifying apparatus. This is the fine adjusting screw. This one is the fine adjusting screw. This one is the coarse adjusting screw. This one is the coarse adjusting screw, and this one is the fine adjusting screw. You will have a little bit difficulty in adjusting from the uniocular microscope to the binocular microscope, but the principles is the same. Rather, the binocular microscope has got an advantage of a self-illuminating apparatus as well as a binocularity of the vision. The binocularity of the vision. Now, what is most important thing is that I will be telling you about the resolution and the magnification. You have to read this, and the question that are going to come are, what is the magnification of the microscope? The magnification of the microscope is the product, that is the multiplication, the product of the eyepiece and the objective. If the eyepiece is here 10x, please come here. Eyepiece is 10x, and the objective is 10x, then the magnification will be 10 into 10, 100. If it is 40, the nose piece 40, that is the objective is 40, and the eyepiece is 10x, then the magnification will be 40 into 10, that is 400. Similarly, for the oil immersion objective, it is 100 into 10, that is 1000. So the magnification is the multiplication of the multiplication or the eyepiece into the objective. Very simple. But resolution power of the microscope. Now remember, what is the resolution power of the microscope? The resolution power of the microscope is the ability of the microscope to separately distinguish between two different organelles of the cell. That is to be understood. I am repeating it, and you can see the video repeatedly again and again to memorize this thing. That is, the resolution power of a microscope is the ability of the microscope to distinguish differently between two different organelles distinctly. The more distinct it becomes, the resolution power is more. That's why the electron microscope is so high power in its resolution capability, that it can distinguish two different, even the strands of the DNAs, etc., etc. Now, what is the important thing is that we can put our eyes here, and we can see it, and then focus upon the object below, that is on the stage, and then we can see the thing. What is most important is that we just see the low, we just fine tune the high, we fine tune the coarse fine adjusting screw, and we can see the object below that is being focused here. The binocularity of the vision, gives you an idea, gives you a very good reason for less eye strain and a nice good comfortable view of the object focused. That's all you need to know. You don't need to know much more about this thing. Two things about that, and oil immersion objective. The final thing I will be telling is that when you put the slide here on the stage and put the clip here, we put one drop of oil. That oil we use cedar wood oil, CEDAR, cedar wood oil. That oil has a peculiarity of having a refractive index close to that of glass 1.5. So what happens is the light emerges from here, is being impinges upon the this is the central portion of the stage when my finger is jutting into, and there is a slide which is made of glass, so 1.5, then the cedarwood oil 1.5, and the oil emulsion objective touches it, dips into the oil, so all the media are 1.5, so there will be no diffraction or lateral refraction of the light, so there are no optical aberration. The objectives, the organelles of the cell will be seen perfectly in a beautiful manner. This is all you need to know about microscope later on when you experiment upon it. Thanking you.